Hello, my name is Daniel Mullaney and we are filming an instructional video for SciTech Process Solutions. Today we're going to be discussing recipe designed for a spin rinse dryer system. Here we have a fully refurbished unit by SciTech Process Solutions, minus the EMO switch which will be installed, and we have our state-of-the-art touchscreen S1 controller set up with the system. If you take a look here, I have all of the recipe items zeroed out other than the RPM, which we have a minimum setting for. So first let's go into our recipe design screen, and now we're capable of programming each one of these. So first let's talk about the rinse. The purpose of the rinse on a spin rinse dryer is to do a quality rinse of the cassette and substrates prior to the spin dry portion of the total drying procedure. So the goal here is going to rinse off the substrates that should already be pretty much clean, but they may have some trace chemicals, they may have a little bit of slurry depending on where you're really using the system, or they may be completely rinsed already, and this is just part of your quality rinse to make sure that we have an additional rinse step involved in your whole process. Now, in terms of the length for a rinse step, that's going to depend on your position. Some people have no rinse, some people rinse for 30 seconds, some people rinse for several minutes. And that's going to be part of understanding what your substrates are like prior to getting to the SRD system. For RPM, you're going to want to run at what we call a low RPM. That's going to be about 500 or 600 RPM. Now, you don't want to be spinning too fast while you're rinsing because it's going to cause a lot of turbulence in the chamber. That's really unnecessary. So we'll run at about 500 or 600 RPM to allow the water to wash over the substrates and make sure that they are rinsed thoroughly. So let's go ahead and program that one right now. Rinse, we're going to say 60 seconds. That's a typical one that we see. And RPM, we're going to go with 600. Okay? The next step that you're going to be going into is the purge step. Now, the purpose of the purge step is to start ramping up towards your dry one speed while also purging out any remaining water that's in your DI manifold. So if you don't purge properly, the water that's in the DI manifold is going to sit in there and slowly whip out during the drying process, and it's going to give you inconsistent results, and it could also lead to water spots depending on when that water actually gets kind of whipped out of the manifold. So for that step, we're going to want to add 10 seconds here, and we're going to want to match our dry one RPM. So in this case, our dry one RPM will be 1800. So that's what we're going to talk about next, is our dry one RPM. So for dry one, we're now going to want to spin, well, I'll actually take a step back here. Now that we're in dry, we've gotten through the rinse part, now we're in dry. We want to have a two-stage dry. We want to have a longer time, lower RPM for the dry 2, and you want to have a short time, high RPM for the dry 1. The reason why we do that is we want to spend a short amount of time spinning really fast to whip the majority of the water off the substrates, and then we want to spend a long time spinning more slowly to allow the drying elements to complete the whole drying process of your cassette and substrates. So again, the goal is to whip and sling the majority of the water off at first, and then let the drying elements complete the drying process. Now, all the drying elements are going to be on in both dry 1 or dry 2. The real main difference there is just the time and the RPM. So let's go ahead and program that right here. Their first dry setting for dry 1 is going to be, let's do 90 seconds at 1800 RPM, which, as we discussed, matches our purge. So that's going to be about a minute and a half to whip off most of the water. Then we're going to go to dry 2, and we're going to now run for 240 seconds, and we're going to go back down to an RPM that's similar to the rinse, so the lower RPM. So that's typically what you're going to see. You're going to see a lower RPM setting and a higher RPM setting. In our case, it's 600 and 1800. So to kind of briefly recap the way we want to theoretically design the rinse dryer is you want to rinse at a low RPM, purge out the remaining water in the DI manifold, spin at a high RPM to sling most of the water off your cassette and substrates, and then spin at a lower RPM to allow the heating elements to complete the dry and give you consistent results for your drying process. So we want to thank you for taking the time to view this instructional video for today. I'm sure that if you are having any issues with your drying, a first look at your recipe would be a great place to start, and this could really help you with getting consistent results. If you are having any more issues though, please get in touch with SciTech at 916-797-9000. Thanks so much.